I'll need to fine tune where this position is going to be, and we'll do that after we get our tooling installed in the spindle there. We should still be in the center because we indicated this before, but I've had the DRO off several times and it's turned itself off. I'm just going to go ahead and double check it and use an edge finder and find the middle of this just in case it's off, because we're gonna base our bolt pattern off of this right here. Well, not too bad so far. Oh, I went the wrong way, man. I don't look bad. I'd be curious to what the run out is. We might put an indicator on there and check just for fun. Really needed one more of those extensions. I thought the math in my head added up right. Technically it did. We're gonna be able to drill and tap that no problem. It's just, I didn't think about getting all the way up to the edge of the chuck there with the edge finder, but we'll get it figured out. I guess what I could do is just go ahead and we'll just take a measurement from this surface here up to the jaw using our height gauge, and then we'll just indicate, we'll edge find off the end of the jaw here, and we'll just have to add this measurement to what it is that we're supposed to be off of this ledge. That's the simplest way that I know to get that height there. There's an indicator check on our socket extension. I'm reading 2 thousandths run out right here. So that's actually better than I expected it to be. Pretty good, I think. All right, on the edge finder, 2.5 thou. All right, about what I expected there. Okay. Hopefully that satisfies everybody's curiosity of what our run out is on our big extension there. But I'm happy with the socket extensions. These are not very expensive to purchase. I believe they were less than $50 a piece. And just a good tool whenever you need it for an application just like this. All right, we'll get us a fresh measurement right here. Go ahead and check, make sure it's still on 0. 0. Okay, 2-inch 875. That's what I remember machining it to. So I'm writing this down right here. So we have 0.870 plus 2.875. That is 3.745. 3.745. So that's going to be the distance from this surface to the center line of our holes. All right, there's our touch off. We're going to reset our DRO. So that dimension that we just figured, we're going to have to subtract 0.1 from that, half the diameter of our edge finder there. So 3.745, so that'll be 3.645. Go ahead and drop it down. .645. I've got that long center drill that we can use to just spot the 2 hole locations. And what I've done to kind of verify visually that we're in the right location, I put this jaw up here in reverse just so that we're not looking at the counter bore. And I've been running this up in there and it looks like it's good. I also used my rule, basically 7/8. So the tip of that drill looks like it's 7/8 on a scale, and that looks like it's in the center of that drilled hole right there. So I think we are good to go. We just got to do an offset in the x-axis both directions from 0, because we're in the center, is 1.940 each direction. I like keeping notes up here for my measurement so I don't have to keep looking over at a print. So we're going x negative 1-inch 940 plus 1.940. All right, it turned out that my 1/2-inch center drill wasn't quite long enough because the back of the vise body was going to bump into the ways of the milling machine. So this is one that I made a long time ago. I just silver brazed a center drill into this piece of drill rod right there, and it's doing good. Running nice and true, so now I can come right on up here. Hopefully we can spot face that. So let's get going. All right, 1.940. isn't too bad. I can stand right here and look at it. Just need a spot. .940. All right, well, we got him spotted. Let's see. 3 7/8. Three and 7/8. All right. I guess we can go ahead and move on to our drill bit now. We're going to end up using our standard jobber drill, 27/64 tap size for half 13, and I've got everything in a position. And also, if I spin the camera around, you see back here, I've got 1 inch of clearance between this and the machine ways there. Our depth is 3/4, so I'll probably go just a little bit past that. And I've got it chucked. The tip of the drill isn't running 100% true, but it's going to be good enough. That's why I went ahead. I found this other center drill that I didn't see over there earlier, and that was able to get me a better center cut in there. And I think that drill is going to follow that just fine. But if we turn it on, doesn't look bad, but I can see just a little bit of run out. But that tip should follow that center in there now. So once we get the full radius or the full diameter established on the casting there, I'll set a 0 and we'll go just past 3/4 depth. Now it looks like our full diameter. Just stop it so it don't chatter. I'm gonna 0 out our Y. And then we'll go ahead and continue on with our cut. All right, well, that wasn't too bad. I had a little bit of chatter in there, but it got the job done. So let's go ahead and offset it and drill our next hole. I'm excited about that. I've been really excited to see that operation done for quite a while. I don't have a real convenient way to cut a chamfer on that. I don't have any kind of extension or anything for a chamfer tool, so we're just going to use the Noga. And I'm just going to hand do it, hand cut it. I did a good job, and we can come back and touch it up after we tap it. Just trying to keep it straight. That's not bad at all. All right, so I've actually got a new old stock set of Morse taps right here. These are brand new. I don't think they have ever been used. So we'll use the taper tap or the starter tap, and then we'll go in there with our plug and bottom to clean it out. So I think that's going to work pretty good right there. We're just going to hand tap it. Got a spring-loaded center here that we're going to put into the drill chuck to support the end of the tap wrench. Do it in this manner right here. Just making sure everything's going to work good. Yep, that's going to work fine right there. Now I do want to, let me back this out. I'm going to use some of my anchor lube. I like the anchor lube whenever we're tapping cast iron. It just seems to work better. All right, we got some anchor lube on there. There's the bottom. That's a good looking tapped hole right there. All right, we're going to go in there with our plug tap now. If I need to after that, I'll check it with the air compressor. I'll check it with the jaws and see if our bolts tighten up like they're supposed to. All right, that's the bottom. I want to see if it's going to line up. Looks like it was made for it. Let me find a wrench. Yep, that's it. I remember those counterbores on these jaws right here are like just under the face of that bolt right there. So, making progress. All right, we got one more hole to tap. Well, guys, I think that is going to wrap up our drilling and tapping here. I think we had a really successful drill and tap operation using our Kearney and Trecker mill. Everything worked out fine. I'm real happy with these extension sockets, you know, the Morse taper extensions. They worked pretty good, even though we had a couple of thou run out here on the end. I think that's about as good as you can ask for, you know, tooling like this. But worked out really well. And I've been enjoying being over here on the Kearney and Trecker and using it for some of these operations. As I said before, you know, that's part of my goal for building this Hardtail Vise is I want to be able to utilize a lot of our machines, a lot of our tools, our measurement tools, and just different processes to get it done. And hopefully by now you can see just all of the different things that you have to consider on manufacturing these if you was to go through and try to build these things and sell them, you know, commercially to everybody. There's a lot of different things that's got to be done, lots of different setups. And again, the way that I'm doing all this is just for my personal fun and enjoyment of the shop and the machines and making content for you to share here on the channel. You know, if you was doing this production, you'd have different kind of setups and different machinery to get these things done a whole lot faster than what I'm showing you do, or how I'm doing it anyway. But we're almost done with the dynamic jaw. We still have a couple little things that we need to do. This area right up here underneath the jaw, this still needs to be machined. I'm going to do that on the shaper because that's going to be a super easy operation to set it in the vise over there and reach in here with a tool bit on an angle and be able to come in here and cut that out. That's going to be a simple op there. And then we still need to finish out the two sides of the box here. I said I was going to do that on the Miltronic CNC, and that's my plan there. So I'm going to write a program, and we'll use a couple mill vices and set this guy in there and use a face mill to finish that out and let the Miltronics get in a little bit of this action. So I really hope you guys have been enjoying the series here on building the hardtail. As I mentioned, you know, I want to try to use as many of my machines and tools and processes that I can because this is it's just a fun personal project, and I'm really enjoying capturing the content of doing all the machining on these guys and sharing it with you here on the channel. So, hope you enjoyed, and I hope to see you again on the next episode.